Listo.
Hello, everyone. Welcome to another seminar, another SMAC seminar. And today we have a continuation of last week's talk on Git, rising a little bit the level, a little bit more, and I hope you're getting the gist of Git. And today the speaker is also Ángel, Ángel de Vicente. The talk, as usual, is being recorded, so please keep your microphones off and your cameras off. And then at the end we'll have a round of questions and comments. And if you want to pose a question or make a comment, please use the chat feature, either on YouTube or in Zoom. And you can mark or indicate there if you want to talk, or if you're on Zoom, or if you prefer to someone else, to the moderator, to pose a question on your behalf. Ángel, please.
Okay. Yeah. Thank you, Carlos. So let me share the screen. Okay, you can see it, right?
Yes.
All right. So then, yes, as Carlos said, this is a continuation of what we had last week. I measured that I have exactly the same number of slides as last week, so it should take more or less the same amount of time. So last time I was a bit in a hurry at the end, so I hope today I can do it a little bit more in time, so I don't go over the 1 hour. So the idea of this one is to just try to look at some, let's call them intermediate features of Git. So in the previous talk, we saw some just the basic commands to use Git on your own in your computer without collaborating with anyone. So the idea of today is actually try to learn the basics, especially Git remotes and how to collaborate with GitHub or something, or GitLab or some other remote repositories, so in order to collaborate with somebody else. Okay, so then this is what we're going to cover today. So basically just a super quick review of what we saw last week, then merging that I was planning to do last week, but there was no time. Then I want to spend some time looking at Git remotes, because if you understand properly what a remote is, then collaboration with Git or any of these hosted repositories will be much simpler. And then the last one is just one slide to just show you some of the commands that they are more advanced. We're planning perhaps to have another advanced Git talk in, I don't know, 2 or 3 weeks time. So I will just go very quickly over what type of commands and what type of features we could see in there. Right, so as for the review of last week, if you remember, basically the only thing we covered was this scenario where you're working on your own in your local computer, and you're using Git just to store different snapshots of your work as you go through time. Okay, but you are not collaborating with anyone. And the basic commands that we use was this list. I don't know if I'm leaving any other command that we saw out, but I think basically that was it. So we learn about the basic concepts of Git, the idea of repositories, the staging area, all these things about how you make changes, that you stage them and you put them in the repository. And then we saw some commands, to status for checking what is the status of your work, whether you have made any changes or not. Add to include that into the stage area, so things that you will commit and you will put it in the repository. Then we also saw this remove and move, which actually you don't use that often, but they're still nice to have them there. Then commit obviously is extremely important to put your work in the repository. And then this too is to inspect what you have in the repository. So we saw some of the features of log to actually see the whole history of your repository. And diff is also obviously very important, so that you can compare versions. Okay, and then we learned the basics of branches. So we had this command branch to actually create branches, and then check out to move your version from one branch to the other. Actually, it doesn't have to be always like to a last branch. You can also move to a intermediate commits, things that are not the actual state of a branch, but that's something that, well, maybe we haven't learned how to do that, and it's not that useful in most scenarios. But anyway, you can also do it. So that was for last week. And then the idea today is, well, first to go to the concept of merging that we didn't have time last week. So I explained you last week more or less how you do it. So it's very, the idea is very simple. You have two branches at some point, and you have made some changes to one of the branches, and you want to incorporate that those changes to the branch where you are now, okay? And then you do the merging. There are three types of merging. I mean, this is something that is sort of internal to Git, okay? So you don't have to, it's nice to know about this, but at the end, they all do the same. What you're going to do is incorporate the changes from another branch into your own branch. But there is nice to know the difference between these three types of merging. So you will understand better what is going on. So basically we have fast forward merges. Then we have also what I would call no conflict merges. So this will be the most, well, not the most common one, but at least the most desirable one. And sometimes you will also have merges with conflicts. You will have problems. The Git will not be able to do the merge cleanly for you. So then in that case, you will have to help Git a little bit. So let's just start with the fast forward one, so we understand what's going on in here. So the idea is very simple. Imagine a situation where you have some repository. You have, let's forget for the moment about this branch. You were here at some point, you had a master branch, and you decided that you wanted to do some fix in your code. So you created a hotfix branch that at the time of creation would be pointing here to the same place. And then you made a commit. So now hotfix is here. So it's one commit ahead of master. And then you think that the work is done, that's it. And you want to incorporate that into master branch. So if you look at this situation, then you realize that these branches have not diverged. So the only thing that you have done is apply some changes from here to here. So Git doesn't have to find any things that diverge from one version to the other. The only thing that it would have to do is apply the same changes that you did in hotfix. It would just have to apply the same thing to master, and then master will get up to here. It's impossible to have any problems because there are nothing diverging here. So if you apply the same changes, you will get to the same exact situation. So because Git knows that, it doesn't have to do any work. It knows that this is going to be a merge without any problems. So actually what it will do is just move the pointer. So it will just take master and say, okay, so now I'm going to point here. So it has to do nothing at all. So it will be, even if you have here 1,000 commits, then this basically will be immediate because it knows that it didn't diverge at any point. So the only thing it has to do is, okay, make this point somewhere else. So, and this is the extremely easy, but it's still quite common, okay? Because if you create a branch out of master, you do some work and you realize that what you have done is enough, then you just say, okay, merge master, and it will just move that pointer to the next, to the last commit that you did. So then after you do that, master will be pointing here, and then that's it. That's your merge. So like last week, I have several demos here just to show you how we can do that. So for example, in this case, if we look at this, yeah, let me go. So imagine that we are, if I do git branch, I can see that I'm in master branch. And if I do git status, I see that I have nothing to commit. So my tree is clean. And I can do git checkout -b hotfix. This basically says, start working with the branch hotfix, and if it doesn't exist, create it. Okay, so you could do it in 2 steps. You could first do git branch hotfix, that will create the branch, and then you could do git checkout hotfix, and then you will start working with that branch. Many times you want to do something like this, just in one command, just create the branch and immediately change to it. So it tells you here that we switch to that branch. And then now, for example, I can just create well, add a line to any file. If I do the git status, I will see that that file has been modified. I can do the commit. Remember that if we do the, instead of adding and then committing, I can also do it in one single step with the #a. So I committed those changes. If I do check out master, then basically I'm saying, okay, now forget about the branch that I just created and go back to the master branch. And if I do this one, git branch #vv, so this is for verbose, for more information. So it will tell me not only the branches, but it will tell me also more information. So for example, here, forget about the other ones. We have to worry here about master and hotfix. So in master, we have, this is the hash. So it's, that's the one that master had from the beginning. Then when I created hotfix, that would be the same hash, but then because I created a new commit, that's another hash. So this one is telling me that is ahead, okay? Well, I don't know from this that is ahead, but I know that it's not the same commit. So I'm not in the same situation in master and in hotfix. So now I can do just a git merge. So I say, remember that git merge, you always do the git merge from the merge that you want to incorporate the changes into. Okay, so now I want to get the changes from hotfix into master. So I have to be in the master branch, and that's where I am. I'm in master branch, and then I just say git merge hotfix. So this will take whatever I have done here in hotfix and try to put it in master. And when I do it, you see that it tells me fast forward. So that's what I explained you before. Okay, the two branches didn't diverge, so it's very easy. The only thing it has to do is just actually move the pointer. Okay, you don't really care about the internals, but that's what it's happening there. And then now you see, if I do again git branch #vv, then both of them have the same hash, so they are exactly in the same situation. Okay, so that was the easiest one, and this is but it's still quite common. So that's fast forward merge. The most common one perhaps is this one. You have a situation like this where now we had at some point master will be here, then I created this other branch issue 53. Then I did some work in that issue 53, so I have two commits here. But then, because I don't have to, I can change branches without merging them. So at some point I changed back to a branch, a master branch, and I made some other changes. So now you see this is more of a problem. If I want to incorporate these changes into my master branch, I cannot just say, okay, so apply the same thing, the same changes that I did here, because maybe this commit maybe change whatever function A, and this commit also change function A. So then which changes are we going to keep at the end? Okay, so then Git has to find what was happening in there and try to find a way to incorporate those changes. So what is going to happen is that it will try to look for the common ancestor and then try to see what changes were done here, what changes were done here, and then try to put everything together. Sometimes there will be no conflicts, and Git can do this automatically. Imagine that you have many files. So here you did some changes to file A, and here you did some changes to file B. So then obviously Git can put all those changes together, no problem. There is no conflict, okay? There will be conflicts if you change, for example, the same line in the same file. But if you're changing different files, or even if you're changing different areas of the same file, here imagine that you're adding something in at the beginning of the file, and here you're adding something at the end of the file, then Git can recognize that, the middle part of the file hasn't changed at all. So I just have to apply whatever changes I did here, I apply them at the beginning, and whatever changes I did here, I apply them to the end. And then what it will happen is that at the end, something like this situation you will have a situation like this. Okay, so remember how it was. So here master was pointing to C4, issue 53 was pointing to C5, and then what it does, you do the merge from the master branch, and then it tries to incorporate everything here into this branch. and then it creates a new branch with all the changes. Okay, and if there are no conflicts, then it's basically from the outside is exactly the same as you did for the fast forward one. It's no difference. Okay, so just to illustrate this quickly, so if I have, for example, this clean repository, I'm in master in here, I create a branch issue 53 and I switch to it. I add some something to this file for copy, okay, and then I just commit. So I'm creating a commit in the branch issue 53. Now I go back to my master branch, and then I'm also going to add some line, but to a different file. So now you see I'm adding to readme.md. So I have changes in both branches. I commit this one. This is nice to see what has happened in your repository. So I do git log and I paint a graph. So then you will see like a tree here. So down here is the past and here is the present. So we started off this branch, and then in the branch issue 53, I made one commit, and in the master branch, I did another commit. Okay, so you can see here that this is like a branch coming out of this main master branch. That's what we did. Okay, we were at this branch in master. We did the checkout. So there is another branch, and it's coming from there. But now you see that they are different. So now what I want to do is try to incorporate this commit that I did in issue 53 back to the master branch. Okay, and then I can just do the git merge. Remember that I'm in master branch in the master branch now. I do git merge, and then sorry, this didn't get recorded properly, but this is just the editor. Okay, it will open the editor, so I can enter a message in the for the commit. I will type the commit in there. It didn't. And then it tell me here, merge made by recursive strategy. Okay, the only thing that you see different here is that it was not a fast forward. It had to do something. It had to actually merge those two branches, because in both I changed the same. No, sorry, I didn't change the same file, but it was not one directly descendant of the other. So in one I changed one file, in the other one I changed the other. But it could figure it out by itself. I didn't have to help. And if I do now the git log with the graph again, now you see the situation. This was the master, the two commits in master branch. The commit in issue 53 was here, and you can see by the graph that this one has been merged back to this one. Okay, so then, well, no, previously was this one in master. This one was in issue 53, and now it has merged both and created a new commit. Okay, so that's a commit only for merging both branches. Okay, so that's it for the non-conflict merge. But as I told you, I mean, it's good to understand what's going on, but at the end they are all merges. Okay, so you are doing exactly the same all the time, just taking one branch and incorporating into the other one. And the most difficult, well, not the most difficult one, but the one that you have to give some hints to Git is when you have conflicts. Okay, so when you issue a Git merge, for example, it could tell you there is a problem because both branches try to change, for example, the same line, and then Git doesn't know cannot read your mind, so it doesn't know what to do with that. But it's actually very easy. There is not to worry. The only thing you have to do is you will have in the file, it will tell you, okay, there are some conflicts, and it will show you something like this. So basically it's telling you in this branch, that's what it means here, the head. So in this branch where you are, the version that you had was this. In the other branch, the one that you're trying to merge, the information that you have is this. So now you have to make up your mind. You decide what you want, and this is just you do it by hand. So the only thing you have to do is look at this, decide what you want, and remove all this section and just leave the version that you want to keep. Okay, so I have a version, a demo here, so just to see how easy it is. So let's go quickly through this. So the idea is the same as before, but now I'm going to actually write to the same file. Okay, so in this case, for example, in issue 53, I'm writing a line to this file for copy, and I do the commit. Then I go back to my master branch, and then now I'm also going to write something, but you see I wrote to the same file, also at the end of the file. So obviously Git is going to have a problem. After I commit, here now you can see the graph again. Okay, so I have made this commit in master, and I also have this branch out here in issue 53. And now if I try to do the merge, that's what is going to tell me. There is a conflict in there. I can look at the file for copy, and then this is whatever it was before. And actually I have this region here with this special marker. So this is what I added in the master branch. This is what I added in the issue 53 branch. So I just have to decide. I don't show you here, but I open the editor and I just edit this file manually. And then after I edit it, it will just look like this. Okay, so for example, I decided that these two versions, I should actually merge them by saying another function in master and issue 53. So once that is done, once I have resolved the conflict, I will see that that file has been modified and not committed, so I can just do the git commit. Okay, once I have done by hand, I can do the git commit, and it will tell me just the same as before. So the only, well, and if I can see the graph is just the same. It's like the same as before. It will be this commit here that is actually merged back to the master branch. So this, you have to get obviously familiar with this because you will be doing this a lot of time. Okay, here I'm not going to have time for this. I put demo plus. So if you want to see it after the talk, I mean, obviously solving the problems, the conflicts by hand is a bit tedious. So there are tools for that. So here I put a demo using the software that I use. Okay, I use Emacs plus Magit, and then there is this edif to check differences. So this is much easier. Okay, basically what you will see is you can see on two different windows. One is the one of the versions. On the other side, you see the other version, and then you see also like the final version. So you decide how you want to, whether you want to take the option A, the option B, or you edit it by hand. Is much more powerful. Okay, but we don't have time for that. So if you want to see it, you can see it. You have the link in there for the demo. Right. So with that, we have to go to remotes. Okay. So this, until now, with this, really, you can do everything on your own. Well, not everything, but I mean, you could be quite you could find Git quite useful to work on your own. But if you want to collaborate with others, then you have to understand Git remotes. Okay, and the idea is that you're going to have something like this. Now it's not only your computer, you're going to have several. In most cases, you can forget about this arrow here. So most of the time, imagine that this is you, this is your collaborator, and this is, for example, GitHub. Okay, so you will be doing some local versions here, and at some point you will push to the centralized server here, and then your collaborator could actually pull. You will get those changes in here, and then he can also push, you can get here, etc. Okay, but this is also possible. Okay, so maybe I can show you later. You can also push directly to other computers. So there is not the notion of having a centralized repository. Okay, basically all of them, as far as Git is concerned, all of them are the same. So you could have different type of workflows where you can push to different repositories, etc. But most of the time, probably what you're interested is just this graph, but removing this arrow. So you have a centralized server, and then you push in there to collaborate. So remote repositories basically is anything that is not your local copy. Okay, so for example, when you use GitHub, that will be something on the internet, but actually you can have anywhere. Okay, it can be located. You can access a remote repository by SSH or even in your local machine, etc. Okay, but most of the time, yeah, it will be some service like GitHub or something like that. And then the commands that you will have to learn actually is mostly, well, you will have to learn how to push your changes to the remote repository and how to pull or get the changes that have been done in the remote repository. And GitHub, GitLab, Bitbucket, all of these are just online repositories. They're no special in any mean, okay? So they are just like repositories like you could have in your machine. The only thing is that they are online, and then also they add some extra features, okay? So they have some stuff for example, continuous integration, continuous development. They have like a ticketing issue to solve problems, etc. But at the end of the day, as far as Git is concerned, it's just a normal repository that is not in your machine, okay? It's somewhere else. And then for the remote branches, this can get a bit confusing, okay? If you read, for example, the book here, the names sometimes are not used very always in the same sense, so it can be a bit confusing, but actually it's quite easy if you understand the concept. Just three concepts. I'm going to call them like this. So you can have a remote branch. This is just going to be a branch that is not in your computer, okay? It's in GitHub, for example, in a remote machine somewhere in the internet. Then these two are local, so that will be in your local repository. But then the remote tracking branch would be like a local bookmark to that remote branch. I'm going to show you now some figures, okay, to clarify this. But all this, it will be local. So there will be, you will have some like bookmarks pointing to whatever branches are in the remote repository. And then obviously you will have the local branches. That's the ones that you have been working until now, okay? But then you can link all this together. So for example, you can say, okay, this one of my local branches is going to be tracking a particular branch in the remote repository. Basically what that means is that when I want to do a pull or a push, I don't have to specify where I want to get the data from. I will say, for example, imagine that there is a branch called master, which is there by default. So I want to say my local branch master is tracking the remote master branch. So then whenever I do a push, Git already knows that it has to push my master data to the remote master branch. And when I do a pull, it knows that it has to get the information from the remote master branch back into my local branch, okay? Let's see with some figures that I think this is going to make it easier. Well, these are the commands that we're going to use. Not many, actually. Clone, pull, push, fetch, and merge. Well, merge we have seen already. And then the other ones we'll see with some examples. So this is what you would have, for example, if you use GitHub. Imagine that this is the first box here. This is a remote computer, and it has a repository that you want to start working with. So then this will be remote, and all this box here will be a local. So when you do a git clone, this is just the most basic command that you need. It will take that repository and make bookmarks or make a backup or copy, whatever you want to call it, here locally, but those will be like the remote tracking branches, okay? So for example, if when I do this, by default, I told you the other day, when you do git init, a master branch is created. When you do a git clone, the remote location is automatically called origin, okay? You can have different remotes, but this one internally, it has an alias and it's called origin. So basically it will take everything from there and it will just copy them in some area here in your Git directory. So this will be remote tracking branches. So basically it knows that they come from this place because by default, when you do git clone, it will be called origin and it will store them for you. You don't work directly with this, but this is like a backup copy of this remote repository. And then after you do the git clone, at the same time, it will take the master branch. Doesn't have to be always the master, but let's assume that it's, in this case, the master branch. I mean, it's the main branch. And then it will create a local branch that is tracking this particular one. So basically, when you do the git clone, every connection is done for you automatically. So it will create this remote called origin that it knows that is pointing to that directory, to that repository. And it will create this local branch that it knows that is tracking this one. So this is very convenient because this is very common. And then, for example, if you do work here in master, when you push, it will know to follow all the arrows like this back to this remote repository. When you do a git pull, it will pull from here and it will come back to this. Because when you do a git pull, it knows that it's tracking this one, origin master, and it knows that origin is at this location. So it will just grab everything from there. Okay. And so, for example, if I just show you some commands, assume that I do this git clone command. I don't do it because it takes some time, but assume I did it before. So I can, with the remote command, I can see what the remotes are. So this is just an alias, okay? When I did the clone, this is the name of the remote origin, and this is the address. So it's telling me that if I use the name of the remote origin is this one. And it's telling me here, fetch and push, okay? So in more complicated settings, you can have different remotes for each of these things. But in this simple case, basically it's telling me whenever you're going to do a fetch, I'm going to grab the information from here. Whenever I do a push, I'm going to push the information here. And this is quite common. So Git does it automatically for you, but you could do it by hand and modify this thing. So maybe you are interested in fetching from one place, but pushing to another and things like this. So for example, I can also see what branches there are in this origin. So in this remote repository, so I can do git remote show origin. So we know that origin is whatever it grabbed from there. But actually now, after I do the git clone, a copy of that is stored in my computer. So after I do the git clone, I could just turn off my Wi-Fi and continue working. Okay, and I could do this. So I could actually go and say, okay, show me what is in origin. So it could tell me the address. It could tell me which branches they are in there. And also you see here, for example, that it has created these local branches and it tells me what is the connection. So it tells me master merges with remote master. So whenever I do pull, it will take the remote master and will merge it into master. Whenever I do a git push, it tells me that master pushes to master. Okay, so that's, you have all the relevant information there. If I do, for example, remember, if I do git branch, that will show me my branches, but by default, it only shows you the local branches. Okay, and as I told you before, when you do a git clone, it would only make a local branch that is the main one. It's not, technically it's not the main one, but let's assume for the moment that is just that. So it will, master is the head branch in the remote repository. So that's the one that is making as local. Okay, so then if I want to see more details, then I could use this command, branch vv all, and then this, for example, will tell me, show me not only my local branches but all of them. So now it's showing me locally you have master, and in the remote repository you have all these branches. Okay, and with this one it's also giving me this information. So it's telling me where in that branch I am, but it's also showing me the tracking branch. So I see that master is tracking origin master. Okay, so that's if you get lost with which branch you're tracking, etc., you can also use this and you see exactly what the situation is. So, and then at some point you can see that now, because there are different repositories, they can diverge as well, right? So this is local. So at some point I cloned the remote repository and I was here, but then I did some work and master advanced to here. But at the same time, maybe somebody else was actually doing work in this remote repository, and master now is here. So now they have diverged. Okay, and that's what you have to try to solve. Okay, if you want to get that information, whatever happened in the remote repository, we use git fetch. And this is what would happen. If you do git fetch origin, now we know that origin is just like an alias for this repository here. It will get every information here, and it will copy into my remote tracking branches here, like the backup copy I told you, okay? It's not going to update my local copies here. So local copies is below. My remote tracking branches are here on top. So this is local to my computer, but these are remote branches. So after I do the git fetch origin, you see that here is bringing all this information here, but for the moment they are not in my local branches. So I can actually review what changes happened there, and then later I could do a git merge. After I have brought these branches to my computer, these are just like a normal branch. It's only that it has the origin prefix in front. So I could just say, if I'm here, I could just say git merge origin master. So then it will try to put all these changes back into my master branch. Okay. And this is nice. Maybe it's not something that you use very often, but at least at the beginning, but you could have many remotes. Okay. So for example, if now there is another repository that I also want to track, you could just do git remote add. So it will add another remote, and then you could do git fetch team1. So then at the end, you would have a situation like this. Now, locally, you have information about 2 remote repositories, and then you can start having combinations. Okay, maybe you want to grab some features from this branch, some other features from this branch, so you can start getting complicated things. Okay. So I'm going to show you now. Wait. No. Okay, what I have here is just that sometimes it's useful. I mean, you don't always have to have a local branch for when you fetch. You can have, so in this situation, for example, here I only have this master branch, and imagine that this one, instead of called master, is called issue 53, like before. So I don't always have to make a local version of that one. Maybe I'm just keeping here, and I just want to incorporate these changes, and I would just do git merge team1 issue 53 back to master. Okay, so you can decide whether you want to keep them as just like a backup copy, or you want to make out of this a local branch. Normally you do a local branch if you want to start working on it. So that's what it's telling you here. Okay, I also have a demo for this, but I don't have time for this. This is just to show you some more details about remotes, but let's not go into there. We're going to see some examples now with GitHub. And this one is just to show you that this is actually, I mean, this is maybe more complicated, but this is useful. Okay, sometimes this is a real state of one of our projects. So for example, in this case, this shows you the number of remotes that I have. So these are all my local branches. Then I have this one, remote origin. This one is in GitLab. Okay, it's not in GitHub, but it's GitLab, a similar one. But then I also have other remotes. Okay, I have a remote in Mare Nostrum. I have a remote in Duna. I access to them through SSH. I also have a remote that is just a regular directory in my machine. And those are useful, okay? Because, for example, sometimes I do some changes here. I want to try it in the supercomputer, and I don't want to make a partial commit to GitLab. So I want to directly send the information to Mare Nostrum, okay, to my version in Mare Nostrum. And if I do some changes in there, I want to send them back to my workstation like this. And only when I'm ready, when it's clean, I can send it to the GitLab repository. So you can get this type of situations, maybe a bit more advanced, but you can do it. So, okay, if you understand remotes more or less, I think now with the demos, it will be more clear, okay? But let's see probably what most of you will be interested in, that is using GitHub or something like that to actually collaborate with someone else, okay? So in GitHub, and similar for GitLab, Bitbucket, and any other place that does hosted repositories, normally you have 2 ways to have a repository. So, well, obviously after you create the account, you can either create a new repository from scratch or fork an existing one. So fork is just like a copy, okay? A copy that you want to grab, and then later it becomes your own, and then you will start doing changes to that repository. So let's look first at the basic one. I mean, if you go to GitHub, for example, the option to create a new repository will tell you something like this. You just give the name, and you can start it completely empty, or you can start with some file. If you start it completely empty, then the repository is created, but it has no data. So it actually, GitHub gives you an example of what you should do, and it's something like this. Okay, I just replicated here the instructions that GitHub tells you when you start an empty repository. So for example, now all of this should be familiar. So after you have created with this, the repository, the empty repository in GitHub, you would go to your machine. And then, for example, in a directory, you will create some files with something like this. And then you would you remember the git init. So it will be a repository, but for the moment, local. Then you add those files, you do the first commit. And then, because now this repository has no idea about the repository that you just created in GitHub, so you have to make that connection. So the connection is first done like this. So basically you're saying, okay, add an alias for a remote. So I'm going to call it origin. That is the standard one for when I do a clone. So I will just create this alias pointing to this address. Okay, this address is the one that GitHub will tell you. When you create the address, the repository will tell you, okay, this is the address of your repository. So here, this is what you would have to do to add that alias. And then you will have to do git push #u origin master. So I told you before, when you do a git clone, the connection between your master branch and the remote branch is created automatically for you. But if you're doing it like this, that connection is not there. So this is just is basically saying, I'm going to set origin as my remote repository, okay? And then the branch, if it's the same, then basically, I mean, Git tries to be helpful, so you're pushing master, and it will know that it's trying to push to a branch with the same name. Okay, so with this, you are doing the connection. You're saying here, this is my remote repository, and I want to push to master, and because otherwise it will complain, I say the remote repository is the one called origin that you just specify here in the previous line. Okay, and then if you do that, then oh no, sorry. Well, if you do that, it will show in your GitHub. I mean, once you do this, it will show in GitHub like that you have pushed the first commit. Instead of showing you directly now this, I'm going to show you that, but with the second way of creating a repository in GitHub. In GitHub, another thing that you can do is just fork or make a copy of an existing repository. Okay, so for example, for this, I just made a test repository. I just took this one, something called git electron, and I created a fork. Okay, you can actually see this is maybe this is too small, but this is another user called JLord, and it has a button here called fork. So if I press that one, then what it will do is just make a copy and put it in my profile. Okay, in my GitHub profile. So then after that, you see here now, this is Ángel de Vicente git electron. So now this is my copy. And obviously, if I want to make changes, I don't have permission to push changes to this repository because this is another user. Unless he grants me permissions, then I cannot make changes there. But after I fork, now this is in my account. So I can do as many changes as I want. Okay, so then after I fork this repository, I can clone it. Okay, so here it will tell me what is the address for this repository, and I could just use the command git clone to get a local copy of that repository. So for example, here again, now imagine I do the git clone command with this repository. Again, it will take some time, so I did it beforehand. So if I do the git clone, then later I can check what are the remote information and what are the branches. So now the remote information you see here that is telling me Ángel de Vicente. So this is my own copy. I forked from JLord's repository, but now it's my own copy. And then it tells me again all the information about the branches. So this is, I have a local branch and I have all these remote branches, which at the moment are exactly the same as the original version, because I just make a fork. I didn't change anything. But then now there are different ways of collaboration with GitHub. The simplest one is when you want to do what I call here a one-man show, right? So you want to have your repository online so everybody can see it and then they can download it, they can use your code, but they are not going to be contributing code to your repository. It's just a way for you to share that to the world, and also to keep it like a backup copy, which is pretty nice as well. So then in this scenario, then it's very easy, because the only thing that you would have to do is work locally, and every time you have a new feature, well, normally the idea with Git is that you would, if you want to add something, you can work in master directly, but I recommend to actually create a new branch. Then you do whatever changes you want to do in that branch, and then when you finish, normally you would just merge those changes, that branch to master, and then push that one to GitHub. Okay, so let's see a demo here, just to see what would be like a regular scenario. So then you would start like this. Well, I see now that I only have one branch at the moment, a local branch, a master that is tracking origin master. So whenever I pull or push, it will go to the remote master branch. If I do git checkout b new feature, remember this creates a feature and switches to that one automatically. Then now if I do git branch, you can see that I'm in this new feature branch. I can add some data to a particular file. I add it, and then I check with git status is there, it's ready to be committed. I do the commit. This is all local. Okay, obviously you always work in the local repository, which is I mean, I think I told you already about this several times, but it's nice to emphasize. It's obviously all this is local, so you could be offline completely and you could still do all those commits, etc. So now, for example, I do this commit, and then, well, if I try to do a git push, this is what it was happening before. The thing that I gave you in the example, Git doesn't know by default this branch new feature. It doesn't know where I want to push it. Okay, those connections are not done automatically. It's done automatically for master when you do the git clone, but for new branches like this, is not done automatically. So if I want to push this branch to the remote repository, maybe because I want to show to a colleague, I want to show the work that I did here, then I can create something like this, git push, and I do set upstream. This is the long version. Okay, this is the same that I used before, the #u. So this is just saying, okay, when this branch, the remote repository is in origin, so basically push it there, and by default it will push it to a branch with the same name. Okay, unless you specify otherwise. So now I could push that branch, and now it would be in GitHub. But many times what you do is, well, now if I do this, you can actually see that this branch new feature is local, but it's also tracking this one. So I add it to the remote repository. Many times you don't want to have this feature or small branches in the remote repository, and what you would do is just go back to your master branch and then git merge the new feature. Okay, in this case it has merged without conflict, no problem. And then I push, and now I'm pushing the master branch because I'm in the master branch. Okay, and so now if I see all the information about local and remote branches, I see that both of them are exactly at the same place. They have the same hash, and so I have pushed now successfully to GitHub both branches, both the local one, the new feature, and the master one. Okay, so that is something that you would do if you want to just share your code with the world and you are not expecting to collaborate with other people. This is all you would have to do. Okay, but obviously sometimes you want something more complicated. So for example, well, and obviously if you now go to the GitHub page, you will see, for example, after you do that there will be now there is an option to see all the commits that you have done to a particular branch. So for example, now up to here there will be all the commits by the original developer, JLord. But for example, this would start to be my commits, Ángel de Vicente here. Okay, so the ones that I do locally and the ones that I look to the repository that I forked. Okay, so now most of the times probably you want to start collaborating, so you want to do some collaboration with a small team. And now the idea is the same one. The only problem is that sometimes two people can push to the GitHub repository at the same time. So then it can happen that your local version is not up to date anymore. So before you continue, you will have to actually fetch the information from GitHub so you have an up-to-date version. Okay, so then basically the common thing is when you start working on a new feature, then from time to time you have to do a fetch from the GitHub repository, so you see if something has been added by somebody else. And then if it has been added, then you have to make a merge to your local branch so that you can continue working with the up-to-date information. Okay. I'm going to show you now a demo, but if you want to do it in GitHub, then obviously you have to give permissions. You have to tell GitHub who is allowed to push, to create branches, basically to do whatever with that repository. Okay, so there is one section in GitHub that is manage access. So you can decide whether it's a public repository, a private one, so that is not visible to everybody, only to the members of the team. Then you can decide for particular people, whether they are managers, whether they are developers, etc. Okay, so you would do that inside the GitHub web page. And then now, if you want to do a collaboration, well, basically, let's see the demo directly because I'm running a bit late, but I'm going to do what I say here. Okay, I'm just going to do some changes because I don't want to involve two people. I simulate that I'm two people by working in two directories, one called CP1 and another one CP2, okay? Like copy one and copy two. So each of them is going to make some changes, and I'm going to push them to GitHub, and the other one is going to have to fetch that information. So for example, here, well, you see that I'm in CP1 directory, so I add some line to this file for copy. I commit it, and I push it. So my version, sorry, I just skip this one. So my version of this file, now I have pushed it to GitHub, right? Now, if I check here with git log, I will see that this last commit where I add that line is now, it tells me here in which branches you can see that one. Okay, so it's telling me it's in master. So this is my local copy, and it's also in origin master. So I successfully managed to push it to GitHub. If I now move and simulate that I'm another person, I'm CP2. So now if I look for the same git log, you see I don't see that last commit. I don't see the commit that says added line as CP1. So what I can do is git pull. Git pull is like a combination of fetch and merge. So remember, fetch will take every change that was done in the remote repository, and then it will merge the branch where I am at this moment. It will merge that one from the remote repository. Okay, so you can do it separately, or you can do it with one command here. It's quite common to do that. So if I do git pull, and then now I do git log, then I see that now in my version I also have this commit, the add line as CP1. Okay, so I'm CP2, I'm user 2, but I'm seeing the changes that the CP1 did. And now then, obviously, I can also add something as myself, add line as CP2. And then if I want, I also commit. And well, this is the same as before, the git log, and I can also push it to GitHub, okay? And then now if I go back to user CP1, if I do the git log, the last commit that they see is this one, outlined as CP1. But if I do git fetch, I want to see what the other user did. So I do the git fetch, and it's telling me here the details of what is fetching. Sorry, that one didn't show nicely. This one, only with 3 commits. I can see what is in origin master, okay? Because now I'm in my master branch. I haven't merged those commits yet, so I can see what the other user did. So I know that I can see the commit message. So he did some, he had this line. I can also see the details of the commit. So I can do git show, and here, for example, I'm specifying the hash, okay, of this commit. I could also just do the origin master, but, so I can see the exact details. So I can see here what happened. It shows me this difference output, so I know exactly what the other person did. And then if I'm happy with that, I say, okay, then it's good work. I want to merge it. So I could do something like this. I do git merge. So basically take the changes in origin master and merge it to my branch, okay? And then that would, after that happens, then now you see that the last 2 commits are the line that CP1 added, and now my line as well, okay? Right, so that would be, so with that, you already know how to collaborate with several people. And several people actually can be yourself at different computers, okay? You work at home, you push something to GitHub, later you go to work, and then you want to grab those changes. So it will be the same thing. You just, whenever you're ready, you push to GitHub, and on the other side, you do the git pull. But this one was, and this, I'm almost finishing, okay? This one was without conflicts, which is very nice, but it's not what is going to happen all the time. Imagine that you have these 2 collaborators that start working at the same time from the same commit. So then there will be trouble when you try to push, okay? And again, I'm explaining here what I'm going to do, but let's see directly the demo. So then, for example, imagine like before, I have this CP2 and CP1, okay? So simulated users. So I'm git CP1 dash pull in the morning, just to make sure that it has an up-to-date version of the repository. Then I go to CP2, and well, I already did a pull here. So you can see that the master branch, the one that I'm going to work on, is the same one for CP1 and for CP2, okay? So they are both starting from the same branch. And now the user CP1, for example, is going to add something, some information to a particular file, to for copy, and it does a commit, okay? So nothing new, and it does the git push, so it will send those changes to GitHub. Now, if I go back to, oh, sorry, that was too fast. Now, if I go back to CP2, the user CP2, and if I do git branch VV, so you can see that my what do I want to show here? Well, yeah, you can see that I'm still at E23. Okay, that's the branch that I was at before. So now CP2 is going to also make some changes to this file, and then I'm going to commit them, and then I'm going to try to push them to GitHub. So now what is the problem? That CP1 already did a commit to that repository before me. So now if I try to do the git push, basically GitHub will complain. Basically it's telling me, I cannot push to that repository because somebody pushed before you. So now I don't know where I should push this. Okay, if you read this information, you can, it's a nice message, but basically it's telling you that somebody pushed before you. So before you can push your changes, you should incorporate those changes to your version. Okay, and that's what you can do with, you do the git fetch. So you get all the information from GitHub, and then you can check with git branch VV So for example, here it's telling you in master. So my local copy, I'm in at this hash, but the origin master, whatever is in GitHub, it's ahead one, it's behind one. Basically, it's telling me how many commits is in front or behind me. But let's not worry about that. Basically, it's not. I'm not having the same commit, so I have to sort that out. So what I can do is just do a merge like we did before. So I do git merge origin master. So I say take whatever changes were done in GitHub and merge it to my local master branch. Okay. And in this case, for example, this is like before. I have some conflicts. So it's the same situation like before. Like when you do merge with conflicts, but those branches are local. It doesn't matter. It's the same situation. You have this file and it's telling you you have this conflict here. So you have to do the same as before. You have to do it manually or with some tool. I open the editor and then now you can see the final version. So I remove all this section and I just put change by CP2 with parts from CP1, whatever resolves the conflict. And then I can do the commit. So that merges both branches, whatever it was in GitHub and whatever is local. I commit that one. And then now this would be maybe nice. If you look at the graph, this is the situation. Both of us started here. CP1 did this change that is already it tells me it's in origin master, so it's in GitHub. And at the same time, I was doing this change to CP2. So now before I couldn't push, but because I did this merge, now this local version has all the information from both commits. So then now I can do the git push. I can push it to GitHub. And then if I do now the git branch to give with hash pv to give me more information, it shows me that master is at this hash and origin master, it just tells me, it doesn't tell me anything like here, like behind one or anything. So basically that means we are synchronized. We are in the same place. Okay. So now with that, I have solved the problem. Now the one that is behind is, if I go back to CP1, to the user CP1, he is the one that is behind. Okay. So now you can see that master is a different hash as this one, because obviously he didn't incorporate these changes that I did as user 2. So now if he wants, he can fetch, and again, it's always the same game. Okay, he fetches the changes from GitHub. Let's go over this, that he could see exactly what was incorporated, and then he could do a git merge, and then everybody, sorry if it was at the end. So at the end, if he does the git merge, then he has also incorporated the changes that that CP2 did. Okay, and if you see, for example, here now everybody is in the same commit, my local branch and the remote ones as well. Okay, so that's the game that you will normally do when you have a small team. And I'm going to leave it here because I'm already a bit late, but I just show you very quickly what would be what other things we would have to see. For example, one that is very common, and I wish I had a bit more time to do this one, is to actually what I would call collaborate with the whole board. Okay, so this is you probably heard the idea of pull request. So the idea is that you can ask or get collaborations for people that are not in your team. You don't want to give them access to your repository, but they can still give you information. So the idea that will work is something like this graphically. Okay, so imagine that somebody has a repo in GitHub, and you want you find a bug in that code. So what you can do is, you cannot push directly here because you don't have permission, but you can make a fork. So you make a copy, and then you make changes to your local copy, and you push them to GitHub. Okay, so this is the same repo, but just temporary. So this is what is happening. So you do the changes and make the changes to the GitHub to your fork of that version of the code, and then you can issue a pull request, which is basically nothing but a message to these people saying, look, I took your code and I made some changes. If you want, you can grab them from here and apply them to your copy. And so like this is a very powerful scenario for open source code. So you can you can collaborate without being part of the team. So you don't have full access to the repository, but you can collaborate that way. Okay, so if we have a more advanced seminar, I will give you some example of that one. As an extra, if I'm sure some of you use Overleaf. Overleaf is actually just a Git repository as well. Okay, so you can also collaborate with Overleaf. So actually, in every Overleaf paper, you have a Git repository that you can clone locally, so you can work locally and push to Overleaf. And other people, for example, if they're not familiar with Git, they can edit directly there in the Overleaf interface, and you can pull those changes from the web from the website. Okay, so that's useful as well. And well, for advanced Git, if we do this seminar, there are many things, many more things that they're not maybe. I mean, what I explained in these two seminars is like the basics of the main things that you have to know to use Git. Many of these things, they are not necessary, but they will make your life easy. Okay, I'm not going to go to them, but I'm just going to explain you, for example, this one. This is really nice, bisect. So the idea on this one is that many times you are developing a code and something that was working 2 months ago, now suddenly it doesn't work. And you don't know where you broke it. Okay, you have a lot of versions and you don't know where you broke it. So there is one function in Git, for example, that it will let you create a little script that fails or succeeds depending on what your code does, right? So you have to write a code, and if you exit a number 0, it's like a success. If you exit any other number, it's a failure. And then Git will do automatically. You have to say, okay, two months ago it was working, and now it's not working. And then Git automatically will check out an intermediate branch and will run your script and will check if that is failing or not. So like this, it will separate the branches until it finds automatically in which is the first branch in which the bug appears. And so this is very useful. Okay, so if you introduce bugs in your codes, which I do very often, so then like this, you can actually find which one is the first branch that the first commit that had that problem. And there are many others that are similar. So they are very useful commands, but they are not necessary. But this is, if you use it daily, it's nice to look at all these commands. Okay, and with that, sorry, I'm again a bit late, but I think I leave it there and take any questions if there are any.
So thank you very much, Ángel. Is there any questions? So the example of, let me just ask, I didn't know about the overleaf in Git. So does it make things on separate, does it commit on separate branches itself internally, overleaf, like based on the name of the person to collaborate with?
No, that it's a bit limited. So there is only, let me share the screen. Actually, I can show you. There is, it's a bit limited, but what it will show is like something like this. So actually I have one here. Blah, 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 blah. So it will show as like this update on overleaf. Okay, so there is only one master branch. Okay. So if you update it in the website, when you pull, it will just say update on overleaf. And locally, you can obviously change the message to whatever. So you cannot have different branches, but you can, it's if somebody does the change in the web interface, when you pull, it will show as just change in updated in overleaf.
Oh, that's interesting. So it deals with conflicts internally.
No, I mean, you have to resolve them. I mean, in overleaf, you have a copy. As far as you do the changes only there, then that branch is updated in overleaf. If I also do changes locally, when I try to do a git pull, then it will tell me the same. I can have conflict. Or if I want to push to overleaf, it will tell me the same that I was showing now. It will tell me you cannot push because somebody did the push before you. So then first I have to do the fetch, merge, and then later I can push.
Okay, and you have a SSH. Does Overleaf allow you to upload SSH keys to like identify?
I don't think so. I think the only access is through like this. I don't know if you
Ah,
can
this
see it
random
here.
code. Okay, so it's like public with this random hash.
Yeah,
Okay.
that's right. I mean, I think it's the same hash as the project itself when you create the project.
Yes. Yes. Ah, okay. Okay.
Yeah.
Okay. So there's another question. How do you set up a remote with SSH, like the remote repo that you showed in Mare Nostrum?
How to set it?
Yes, by Isaac Alonso.
Yeah,
Uh,
I think if I where did I show you here, for example, where did I have it? Yeah, like this. So it's just,
so it's not share screen. Okay. If you want
sorry.
to, you want to show share screen, it's not on. It's not on share
Oh
screen.
yeah, sorry. Where am I? Okay. Okay, like this. So for example, yeah, in this case, for example, imagine this one right here. I have this, this is just a external machine, and I just, at some point, I made a clone of my repository in this directory. So the only thing you have to do is when you do the git remote add, just give this. So it follows this syntax. So when it's a HTTPS remote, you specify this one, right? Like when you do the git clone something. So when you want to do the git remote add, you just specify like this. So you specify the SSH protocol, then the username, the machine, and then the directory. So you can have it just like that. And actually, I mean, I'm showing here, for example, you don't even have to, they don't even have to be the same user. Okay. So for example, here I have a remote repository in Mare Nostrum, but it's with another user. As far as I can access to that directory through SSH with this user and with this machine name, then that's it. You can do it. And then afterwards, obviously, you can use like any other remote repository. You can, as far as you have permissions, you can pull and push from here, and you don't have to go through GitHub, for example. So you can push the changes directly to that machine. Did that answer the question?
I think so because Isaac thanked you. Yes, yes.
Okay.
Yes. Okay. Is there any other question?
There is something in the chat, right? But I don't know if it's a question or not.
It was just Isaac's question.
Okay.
Okay. So if there's no more major questions.
No, in YouTube, there's no questions neither.
Okay, then.
The questions will show up when you start trying all those things, for sure.
Exactly.
Yes.
So, yeah, it's very exciting
Sure.
to start.
I mean, this is the type of thing that I promise you that is extremely useful when you start using it. I mean, once you start using it, you wonder how you wrote anything before without this. But it's true that it takes some time. Okay, it takes at the beginning some time to understand how you do the merges and etc. That's why I was suggesting the other day to actually try to find some nice tool, because I think at the beginning is easier. If you do some graphical user interface or something like that, it's more intuitive. There are fewer options, and then once you start understanding how you manipulate all these branches, how you create, and then at the end it becomes automatic. But it's true that it requires some time practicing and finding problems with Git.
Yeah. The book that Ángel introduced in the beginning, that Git Pro Git, is very good to start with to get the concepts and things. Yeah.
Yeah, actually, okay. I all the figures I stole from that book.
Exactly. Yeah. But there are different views. Like for me personally, I initially, when I tried to learn Git, I also tried these graphic user interfaces. But then for me, it was I started to notice that I'm getting confused in the usage of the graphic user interface rather than Git. Yeah. So then I just gave up and I came to the command line, and it was easier for me.
You are an Emacs user, so I would recommend very strongly to use Magit. Actually, it's fantastic.
Exactly. Yeah, with Emacs, Emacs rules. Yeah, exactly.
Is actually much better than anything else that I have used.
Exactly. Yeah. Maggot is great. Yeah. Okay. So if there's no other questions, one final check. No more questions. So thanks a lot, everyone. Thanks a lot, Ángel, for the 2 nice talks so far, and we look forward to the 3rd one.
Okay, thanks to you.
Thank you. Bye bye.
Bye bye.
Bye bye.